Why do Python mutable variables cause unexpected side effects? Have you ever wondered why your Python code sometimes behaves in ways you didn't expect? One common culprit is mutable variables. Let's break this down to understand why this happens. In Python, mutable variables are objects that can change after they are created. Examples include lists, dictionaries, and sets. The key issue arises because multiple variables can point to the same object in memory. When one variable changes the object, all other variables referencing that object see the change. This can lead to unexpected results if you are not careful. Python uses a system called pass-by-object reference. This means that when you pass a variable to a function, you are passing a reference to the object, not a copy of it. If you modify a mutable object inside a function, the original object outside the function is also affected. This can create surprising behavior, especially when you use mutable default arguments in function definitions. These default objects stay the same across function calls, and any changes accumulate over time. Such unexpected side effects can lead to bugs that are difficult to track down. The program state may change in ways that are not obvious from the code you wrote. This complicates debugging and maintenance, as the source of the change might be from where you see the effect. Additionally, side effects can reduce the modularity and reusability of your code. Functions that modify shared mutable objects cannot be reused safely without considering their impact. To avoid these issues, it is best to use immutable objects when possible. Immutable objects, like strings, tuples, and numbers, cannot change after they are created. This prevents side effects from occurring. When you must work with mutable objects, consider creating copies before making modifications. You can use techniques like list comprehensions or the copy module to protect the original data. Another helpful tip is to use none as a default parameter in your functions. This way, you can initialize mutable objects inside the function body, which prevents unexpected changes from persisting across calls. Understanding the difference between mutable and immutable types is essential for writing reliable and predictable code. By being cautious with mutable variables, you can avoid unintended side effects, making your programs easier to read, debug, and maintain.